In this video, we're going to see an alternate method for polynomial division. In this alternate method, we just take our area method for multiplication and wind it backwards. In other words, we just reverse the multiplication process directly. Now, some people find this method easier. Some people find the method that we've been using in the previous videos easier. You should choose whichever method you think is easier. I personally prefer this method. I like that it's a little bit easier to see what's happening. I also like that it takes up a whole lot less space. The other method that we've seen in the previous videos in this section is the standard method, at least in the US. So you should be familiar with that method. You should know what it looks like. You should be able to follow when someone else is doing it. But if you're working on problems, you can use this method if you find it easier. So how do we go about reversing multiplication? There are some things that are obvious when we multiply that are less obvious when we're dividing that we need to work out in advance. And we also have to deal with the possibility of a remainder. So our first step is to guess the degree of the result. Now, when we do the division, the leading term of the result will come from taking the leading term of the dividend divided by the leading term of the divisor. So if we look at the degree of the dividend, in this case we've got that 2x to the 5th, so the degree is 5. And the degree of the divisor, here we've got this 2x squared, so the degree of the divisor is 2. The degree of the quotient for the leading term will be taking x to the 5th divided by x squared. We're going to get a degree of 5 minus 2 equals 3. We needed to know that for our setup because it's going to tell us how many columns we have and what each column represents. The number of columns we need is 2 more than the degree. So it's going to be 3 plus 2. We'll need 5 columns. So 1, 2, 3, 4, 5. And I'm making these kind of wide, 2 squares on my graph paper here, because I'm going to write terms of polynomials in these boxes I'm making. Now we need 1 row for each term of the divisor. We're going to write the divisor down the side. If our divisor has any 0 terms, we need rows for those as well, or our diagonals will be funky. So here our divisor has 3 terms, so we'll need 3 rows. So 3 rows, 5 columns. There's my box for reversing multiplication. Now what am I going to write inside and outside of this box? I'm going to start by writing stuff outside. I'm going to label the columns in descending order, so with descending degrees. The degree of my answer is 3. My first column is going to be an x to the 3rd term. Then I'll have an x squared term, an x term, a constant term, and then my last column is going to be my remainder. The reason I needed a row for each term in the divisor is I'm going to write my divisor down the left in descending order. So I've got a 2x squared, a negative 5x, and a 1. And now I write the first term of my dividend in the upper left-hand corner. So my first term is this 2x to the 5th. I put that in the first box. And now I'm done with my setup. I'm ready to start the process of reversing multiplication. And in fact, that's my next step. I'm going to reverse multiplication to figure out what term goes above my leading term. So What do I need to multiply by 2x squared to get 2x to the 5th? Well, I need to multiply that by 1x to the 3rd. 1x to the 3rd is going to be the first term in my quotient. Okay, so that was a divide step. Next comes a multiply step. I'm going to multiply to fill in the rest of the column. So my 1x to the 3rd times negative 5x is a negative 5x to the 4th. 1x to the 3rd times 1 is a 1x to the 3rd. Okay, I've multiplied to fill in the rest of the column. This next step is hard to say but easy to do. Every diagonal has to add up to the corresponding term. So to figure out what goes in the next empty box in the top row, I need to look at the diagonal that it's on. So here is the next empty box in the top row. It's on this diagonal, which corresponds to the x to the 4th term. I need it to add up to negative 9x to the 4th. To figure out what I need there, I'm going to take the result that I want and subtract what I already have. Negative 9 minus the negative 5 I already have. I need a negative 4 there. I need a negative 4x to the 4th. See, now these add up to negative 9x to the 4th. I'm using subtraction to find the missing number in an addition problem. So that was much harder to say than it was to do. And now I go back and I repeat the process until I filled in the top number in the remainder column. So until every column has a top number. So reverse multiplication. What do I need to multiply by 2x squared to get negative 4x to the 4th? Well, I need a negative 2x squared. Negative 2x squared times 2x squared would give me negative 4x to the 4th. Now I multiply to fill in the rest of the column. Negative 2x squared times negative 5x is positive 10x to the 3rd. Negative 2x squared times positive 1 is negative 2x squared. Now here's the top box in the next column. It's on this diagonal. So this diagonal is x to the 3rd. It needs to add up to my x to the 3rd term, which is 19x to the 3rd. So I take my 19 and subtract what I already have along here. I have two terms. I already have a 10 and also a 1. 19 minus 11, that's 8. So I need an additional 8x to the 3rd. Notice these now add up to 19x to the 3rd. Okay, now I'm back to my reverse multiplication step. What do I need to multiply the 2x by to get an 8x to the 3rd? Well, I need to multiply it by a positive 4x. Multiply to fill in the column. 4x times negative 5x is negative 20x squared. 4x times 1 is just 4. The The next empty box in the top row is here. It's on this diagonal. Which has x squared terms. The x squared term in my dividend is negative 20x, so I need to get a negative 20. And I already have negative 20 minus 2. If the signs are giving you trouble, you can just use a calculator on this. This gives me a positive 2. I need a positive 2x squared in this space. All right, notice positive 2x squared plus negative 2x squared is 0, plus negative 20x squared gives me negative 20x squared. All right, we are almost done now, right? We need another round of reverse multiplication. What do I need to multiply by 2x squared to get 2x squared? Okay, that's pretty easy. That's just 1. Now I multiply to fill in the column. 1 times negative 5x is negative 5x. 1 times 1 is 1. The very last empty box in the top row is in the remainder column now, but the diagonals still need to add up. I have x terms along this diagonal. My x term is going to be 7x. So I need a 7. I have a negative 5 plus 4. So what I need to put in that box is an 8. I need an 8x. 8x minus 5x is 3x plus 4x is 7. So that diagonal now adds up to 7. That was what I was supposed to repeat until, right? Now I fill in the rest of the remainder column to get appropriate totals. So the remainder column, I've got also this diagonal with the constants on it, right? That needs to add up to 3. So I'll take 3 minus, I already have a 1, is 2. I need a 2 in my remainder column. The quotient we just found is x to the third minus 2x squared plus 4x plus 1. And then our remainder was 8x plus 2, and we put that over our divisor, 2x squared minus 5x plus 1. Now again, some students find this easier, some find it harder than the other method for long division. You should use whichever method you prefer.